So a 2 kg ball rolls from rest from point A on a frictionless track A, B, C, D. So our tracks will always be frictionless because we always want mechanical energy to be conserved. Mechanical energy is conserved. Probably we know what that means, but to go through it again, as shown below, the horizontal section BC, there is BC, they say it's perfectly horizontal. Of the track is 5 centimeter above the ground. Okay, that is also indicated. The ball reaches point D 30 centimeters above the ground at a speed of 1.71 meters per second. So you go into, what I like to do is I just want to show the information also on the sketch. That's the first thing I want to do whenever I get a question. So just draw the ball at point D, and then I'll show that the speed at that point is now v equal to 1,71. So 1,71 meters per second. And now I can go to the questions. So the first question says write one term for the following statement. So you just need one term to replace the statement. So basically they give you the definition. Yes, do we have a question?
Yes, sir.
Mm-hmm.
Sir, I just wanted to ask a question, sir. When do you use the motion equations? Because I see in one of the activities that we did at school, sir,
Mm-hmm.
we used a motion equation. So basically, those four equations we were using in term two.
So
Oh
can
yeah.
I answer?
Yes, you can.
So Angry, so you can correct me if I'm wrong, but then we only use equations of motion on a straight line, and mechanical energy majority of the time is not used during while we're using straight lines. So the only reason why we use equation of motion is when we have to calculate on a straight line. We also had that activity.
Yep. That's correct. So the equations of motion, those four equations that we learned, they apply for constant acceleration. That is like the simplest way we can put it scientifically. They apply only for constant acceleration. And for this kind of problems, for when we use energy principles, we don't always have constant acceleration. That's the thing. But you can use equations of motion for this. It's just not advisable because they're only going to apply, as Tapelo said, they're only going to apply for motion in one dimension where you are sure that there's constant acceleration. Because in this case, if I start from here and then move all the way to B, I can call that one dimension. Then I can use equations of motion. But when I start to go from there to BC, I expect to have constant acceleration there, but of 0 as well. So there won't be any acceleration there. So you will have to break down the problem into parts, whereby using energy, we don't really have to break the problems into parts like that. But I'll show you how you can use both. For example, you remember that example where we're dropping a ball? That is a motion in one dimension problem. So you can use equations of motion as well as energy principles. So they always apply for constant acceleration. Every time you see motion that is constant acceleration, obviously you are allowed to use the motion equations. But you will see energy questions, and in the memo they will expect you to actually use energy principles, which is just mechanical energy conservation. I don't know if that makes sense. In grade 12, that is the only place you can use both. But for you guys, you only need to use energy for energy questions.
Yes, sir.
Okay, yeah, thank you for that question. It's very important also. Do we have another question?
No, sir. I pressed the button by mistake.
Okay, that's cool. So which term can we use for this? The sum of gravitational potential energy and kinetic energy.
So you can use a half mv squared. Yeah, EK is equal to a half mv squared.
Oh, write down one thing. The sum of
Yes.
gravitational potential energy.
Oh, and
Oh,
then the
what is this? Mechanical energy.
So yeah, the question says we are looking for one term to describe what the statement is about. So in other words, is the opposite of write the definition of something. In this case, they give you the definition and then they ask you what are we defining. And this definition is mechanical energy. We don't need an equation, but we do need the weights. The equation that we were given was correct, but we just wanted a weight for this one. So this will be mechanical energy. Good. Then we have to calculate the mechanical energy of the ball at D. There's point D. And then what I want to mention for this. Okay, there's a lot of wind today on my side. I don't know if it's audible on your side, but it's fine. So for any question that you're asked to find mechanical energy, just make sure that your given data is in the SI units that we need. For example, if you check here, the distance is in centimeters. We can't use centimeters for this. Yes. So how do you convert that to meters?
Pretty divided.
So we're going to divide by
1,000.
no. It shouldn't always be 1,000.
100.
100,
Yeah.
yes. We're going
So
to
isn't
divide by
1,000? Yeah.
yes.
So isn't 1,000 when we have milliliters and liters?
Yeah, 1,000 is when we have millimeters. Yeah. So centimeters will be 100. Yep. Therefore, this is equal to just 0.3 meters. Okay, cool. Then the 5 meters as well, we might want to convert that one as well. So this one will be
0.05.
0.05. Thank you. Meters. But we're only looking for mechanical energy at point D. So if they ask that, what you just need to do is just to say EM at point D. Yep, is equal to, we know that EM is the sum of potential and kinetic. This equation is given in the formula sheet. I can write down what potential is, and then I can just say at point D if I want, and then half mv squared also at point D. Then I can substitute the values. I was given the mass, it's 9.8 for gravitational acceleration, and h at D is 30 or 0.3 meters plus 1/2 2 into the velocity there is given as well. That's why they want you to actually find the mechanical energy there, because they gave everything. Yes, do we have a question?
Yes, sir. I don't know. I was gonna say, sir, that with your screen, sir, it was showing like just your profile for a second.
Oh, okay. Now it's
So
back.
yeah, that's I wanted to ask if there's a problem or something. But
Okay.
anyway, continue, sir.
All right, is it back now?
Yes, sir, it's back.
All right, okay, cool. So then you find the answer for that, and then I want someone to explain how to find 5.2.2, the initial height h of the ball at point A. How do we answer that one? If you found the answer for this, you can let me know. Yes.
Yeah. Also, wait, so let me.
Sir, can I try?
Yes, you can try.
Sir, can you Can you use that statement where you say the EM at A? Okay, no, never mind, sir.
No, you actually had it. Continue.
So like the EM at A is equal to the EM at D.
Yes, that's very correct. So after you do that,
Oh,
you found the answer for EM at, remember EM is equal for any point on the track. As long as the ball will reach that point, EM is always the same. So that's exactly what I'm gonna
yes,
do.
sir.
Yes, now that I know the answer for EM at D, I can use that to actually find whatever I'm missing at point A. If I write out what EM at point A is, that's just EP at point A plus EK at point A, and someone will calculate EM for point D for me. Therefore, I can write out MGH at point A plus 1 over 2 MV squared at point A. That's also equal to EMD, which I already have the value of. And I can substitute the values that I have for point A. And you see there's a keyword here. They say the ball rolls from rests. What are they trying to tell us there?
Said 0 meter. The EK is 0 meters per second. Zero joules.
Yes, EK is 0 joules, or velocity is 0 meters per second, same thing. So I'm just gonna substitute my values for substitution here, and then H at A is just H, multiply on plus half 2, velocity is 0, making the whole EK 0. Then yeah, if we find the values for EMD, we can find the H.
Yes, sir.
All right, yeah, that's how to solve that one. And then there is question 5.2.3 saying calculate the speed of the ball when it moves from point B and point C. How do we work that one out? I need to also grab a calculator to find the answer for this one. So we're looking for the speed at point B and C.
Well, so I'm just gonna calculate
So
wait,
isn't it like
Yes, one of you can talk.
so can you please like show me the statement once again?
Okay, it says, wait, we on 5.2.3 says calculate the speed of the ball when it moves from point B and point C. If the screen is not visible on your side, let me know.
Okay, so you can scroll back down.
Okay. So here we're just calculating this. I'm just gonna...
So can't you use so can't you use what is it called? EM, calculating for EM.
Exactly, so we can always use EM.
Oh,
So yeah, do that and
yeah.
then tell me what you get for the final answer.
So can you please scroll up so that I
Okay,
can see the
question.
diagram?
Yep.
Thank you, sir.
Okay. The final answer for H here, I got 0.45 meters. So both of you will try out question 5.2.3 now. Then you'll tell me when you're done.
yes, sir. Sir, can you scroll up again?
To
Not up, down.
down, okay.
down, up.
You'll tell me when you got what you were looking for.
So we're looking for the speed, right?
Yes, we're looking for the speed.
Yeah. So I've got v is equal to 1,41 meters per second.
Okay, 1,41 meters per second.
Meters per second.
Okay, let's take a look at the whole situation here and see if that answer could be correct, just for a sanity check, just to check if you are making a mistake, or like this is gonna help you out to figure out if your answer actually makes sense. So the ball is from rest at point A, and then it has to slide down to point B. At that point, I expect it to be quite fast compared to at D. So
Okay.
yeah, realistically, I expect the speed to be higher at point B, because just imagine a roller coaster or a skateboard just going from rest at A. It's gonna be faster at B, C, and then it's gonna start to get slower at D. So let's just check if we didn't make a mistake somewhere. I haven't calculated it, so if that's actually what you get, we'll just see.
3,29 meters per second.
Okay, did you identify where you made a mistake?
Yes, I did.
Okay, yeah, but that's basically how to check if what you're doing actually makes
Sorry.
sense. All right. Mulweli,
Because,
are you winning on your side?
Oh yes, I was still like busy calculating. So let me just finish quick.
All right. Yes, Tapelo.
So it's not making sense because the height is 0,05 meters, right?
The height at A, or the height at B and C
Height
is
at B and C
0,05.
is
Yeah,
0,05 meters.
correct.
Then the mass of the ball is 2
Mm-hmm.
kg. So then if I do that, half mv, we don't have v, right? So it's going to be half of 2
Yes.
v squared plus, okay, so no, I see where I'm going wrong. So.
Okay. Let's wait for Mulweli to actually find her answer. Then we can look at how to do it. 5.2.3.
So what is the EM at point A?
Say that again.
What is the EM at point A?
At point A, it should be
Mechanical
8,80 joules. Since it's going to be the same for any point, we found the EM at D, and that should be exactly the same as the one at A and also at B and C.
What is the...
So I got 8,80 joules when I was calculating.
Thank you, sir.
All right.
Sir, I got 0,98 meters per second.
0,98. Okay, also that one has a bit of a problem because the speed should definitely be greater than 1,71. Definitely.
So you said the EM. So you said the EM was 8,80.
Yes, that's if I didn't make a mistake when I was calculating, because I used my phone. but I don't think I made a mistake. That answer looks to be what I expect. Or is it? Let's just see. Let's just verify.
Hmm?
So we're supposed to multiply out this just to check if we do get 8,80. Yep, I think that is what we should get. So I'm not sure what happened in your calculations or whether the question has a problem itself. But
No, wait.
yeah.
Sir, can you please show the solution answer?
Yeah, we'll work it out now.
Like how you got to the answer?
Yeah, we'll work it out now. Just was trying to wait for anyone else who's trying out the question again, but this is what we have here on this sketch. Can you all see on 5.2.3?
Yes, sir. Also,
Yes,
I have
sir.
to answer.
Yes, what did you get?
I got 2,80 meters per second.
Yeah, that one does sound right because it is greater than 1,71, and that's what we
Yeah.
expect. Yeah, we only expect a value that is greater than 1,71. Not to say it is correct, but in terms of making sense, it does make sense. But okay, let's look at what we should do for just future reference so that you'll never get this ones wrong. So you're gonna have your given data. In this case here, we have the speed is 0. I'll just call it VA, and then we are looking for VB, but we do have the height at B. And take note that the velocity at B will be the same as the velocity at C. That's mechanical energy. At the same level, we'll have the same velocity and we'll have the same energy at the same level. Okay, then what we need to do is just to set up the equation for conservation of mechanical energy, that just EM at A. And this is always what we do. If you look at this, it's always what we do. So no reason to get this one wrong actually. Equal to EM at B. We already know the EM because this is indeed equal to EM at D. I can do that and say the EM should be equal to 8,80 joules. And then with this, because I'm not looking for any value at point A, I can go ahead and just discard this thing here for A. I can just get rid of that. Then I can work with EM at B. It doesn't matter how you tackle it, but what matters is that the EM is the same. And if I have the value for EM, I don't really have to go back and forth to try and do the mgh plus half mv squared for 2 points when I already have the EM. So I can just go and say EP plus EK, this is at point B, is equal to 8,80. Therefore, I can expand EP to mgh at B plus half mv squared at B equal to 8,80. And then I can substitute my values now. The mass is 2. The G is 9,8. H at B is from the ground to B, so it's this value, 0,05. 0,05 meters plus half of 2, and then the speed at B is what you're looking for, VB squared. This is equal to 8,80, which is our total mechanical energy. Then we're just solving for VB now, which means I'll have to multiply out 2 times 9,8 times 0,05, and then I'll go and subtract the other side with that. So that will be 8,80. By the way, I find 0,98 for this, plus half of 2 is just 1. So this is the same as just plus VB squared equal to 8,80 Then I'll take the 0.98 to the other side, it becomes negative. And now VB is equal to 8.80 minus 0.98, and that is equal to 7.82. By the way, this is VB squared. Then to find VB, I have to take the square root. What is the square root of that number?
I don't know.
What do we get for the square root of 7.82?
So 2.80 meters per second.
Right, which is the
Yeah.
final answer that Tapelo provided, and that's correct. But guys, the procedure, I think we just need to just take a deep breath. The procedure is exactly the same all the time, it doesn't change. We always look at 2 points. That's it. That is if we don't have the mechanical energy in the system. But if we do have the mechanical energy, then I just need to look at the information for 1 point. What I mean by this is, let's say I didn't have the mass of the ball, and I just know that the height at A is 0.45 and the velocity at A is 0. Then I'll just say the EM at A is equal to the EM at B. Therefore, I'll just write it out, mgh at A plus half mv squared at A is equal to mgh at B plus half mv squared at B. So I write this out like this if I don't already have the mechanical energy of one of the points. Now I did have it, so I could just write 8.80 instead of writing out all the terms for A. But I can do this as well. There's nothing wrong with doing this. Then I can just go ahead and substitute everything. The first thing I would want to do is just to cancel the m because it's recurring in each of these equations. But you don't have to cancel it because they'll always give you the mass. I think it's only in grade 12 where they don't actually give you the mass. The HA is 0.45 from what we calculated before, plus 1/2. VA is just 0. This is equal to 9.8. And then H at B is 0.05 plus 1/2 VB squared. And with this, we'll find the exact same answer if you actually calculate. So you have 2 ways of doing this, just finding the mechanical energy at 1 point and then working out the other points, or just relaying all the information at 1 point, at 2 points. Let's see if I get the same answer. 0.5 there. And then multiply this by 2, I get exactly the same answer. After taking a square root, I get 2.80 meters per second. But I am interested in seeing what you did, where you went wrong, and like all the methods that you did that ended up giving you a wrong answer. Then we can just work from that. So you'll just take a picture of those, send it in the group, then we'll discuss it after. But does this make sense? I really want energy to be the one chapter you are 100% sure on, guys.
Yes, that does
Yes,
make
that
sense.
makes sense.
Yes, okay. Let's see the last question on this questions that I have. It says the 2 kg ball is now replaced with a 4 kg ball. Okay, you see, they like these questions a lot. Changing the mass. So now we are increasing the mass. Immediately, what are you thinking before you even read the statement below? What do you think they want to ask you, and what is your answer basically?
If the mass changing is going to affect the anything, it's gonna
Yes,
affect something
exactly,
in the equation.
exactly.
So
So
I'd say if it's gonna, okay, like Tapela said, sir, they would ask you if it's gonna affect something. So I'd say the something might be the speed.
Yeah, so that's correct. They are going to ask you if it's going to change something in there, usually the speed, of course, or kinetic energy. No, let me not say kinetic energy, let me say the speed, because there will be a difference between kinetic energy and a speed. Speed is not a function of the mass. We already see that a lot, and then I also cancel the mass as well on another method for 5.2.3. So this question here says, how will the speed of the 4 kg ball compare to that of the 2 kg at point D? Choose from greater, smaller, or equal to, and give a reason. So it's definitely going to be equal to, and I mean 2 marks, this means they're going to mark 1 for equal to and then 1 for the reason. So we mainly just need 1 reason. What can we say?
Mass does not affect.
Yeah, something like that. I'll see what they
Yeah.
say if I find the memo of this, but it's exactly what you just said. The mass doesn't affect
Mass
the speed of the
has,
ball. Yeah.
also, can I say that mass has no effect on the equation of
Yes.
the on mechanical energy?
Yes, that also makes sense. That also makes sense. Yeah, I'll see the kind of reasons and options that they have in the memo, and then I'll just send that out in the group so that you can always write the reason that they do have in the memo, because you can write something that makes sense to you, but the marker maybe doesn't think it makes sense. But I'll then give you the reasons to actually write them exactly how they want them. Okay, all right, that was it for this question. 13 marks in total. To me, this one should be quite easy. By the way, they didn't even have to give you, oh wait, let me see. Oh yeah, they did need to give you the speed at D because we don't have the height at A. Yeah, okay, that is good. The issue of, Asimu Mulwedi said she had a problem with the issue of mechanical energy at the top and mechanical energy at the bottom. That is exactly the same thing as what we were doing all along. It's just that in that case, we'll be doing something that goes from top to bottom. And it's always the same thing. It's always, what is the height? What is the height? What is the velocity at the top? Let's say 0. And then the velocity at the bottom is unknown, but the height is 0 at the bottom. So you'll say the mechanical energy at the top is exactly the same as the mechanical energy at the bottom. That's all they're looking for. Therefore, at the top, once again, it's EK plus EP. I like to start with EP, but it's fine with any. EP plus EK is equal to EP plus EK at the bottom. Then you write it out, MGH at the top plus half mv squared at the bottom. I'll just call them initials. And then this is equal to mgh at the top, at the bottom. I'll call them finals, and half mv squared at the bottom, which is final. Then I can just go and write the ones that are zeros. Kinetic energy is 0 because there's no velocity at the top. Potential energy at the bottom is 0 as well. Then I can just, given the height, I can find whatever missing data I need, which is the velocity in this case. But you can see it's always the same kind of equation. You write it like this first, then you can write it like this, and then you can write it in full like that. Is that fine?
Yes, sir.
Yes.
Yes, sir.
Yes. Another thing you can do is just to find, some people like to find the mechanical energy at the top first, and then they'll say mgh at the top plus half mv squared at the top, because you have everything there. Also given the mass of the ball, then you'll have the mechanical energy in joules. Therefore you can just take that mechanical energy in joules and then you can write out this here for the bottom. You can say this mechanical energy that I just found on the top is equal to the one on the bottom, and that's it. That's where you can solve for the missing final velocity. Okay, simple as that. One last example, this one I did try to get the question paper, but couldn't find it. They have this, it's a tree, and then there's another tree here. Okay, and then they say there's an apple here, and there's someone on a swing. They're trying to actually reach that apple, and then the question is, are they actually going to reach it? And this is exactly the same as the stuff that we've been doing as well. They'll say the swing is like, let's take it as 8 meters from the ground, and then someone pushes them, and then they're going to swing all the way to that point. Actually, let's say, okay, I'll just formulate the question myself. I'll just make it a new question because I couldn't find the one that I actually saw, but I'll make it my own question. So let's say we have this scenario, and this person actually reaches the apple, grabs the apple on the swing. So the question is, the person who's pushing them here, what speed should they give them? So what is the speed that they need to actually take the apple from the tree if the apple is actually at 5 meters above the ground? I'm not sure if it's a question that makes sense to you guys, but yep, that is what it is. It's a pendulum kind of motion. We are pushing this person on a swing. They're going to swing from this vertical position. This is a vertical position, vertical. And we need to give them some velocity because we can't swing at that position if we don't have velocity. So we need to give them velocity, which we are looking for, in order for them to reach an apple that is 5 meters above the ground on another tree. How can we solve for that question? Any ideas? What is your thought process?
So by using the mechanical energy.
Yes, we're always gonna go to the conservation of mechanical energy. So we'll just call this point A and point B. Yes, so that is correct. So we're going to say EM at point A should be the same as EM at point B. Okay, then what's next?
Yeah, so
Doesn't make sense. Yes.
So aren't you supposed to say like EK plus P plus EP is equal to EK plus EP?
Yep, that is exactly what you do. EK,
And then
EP at A is the
and then you
same.
write down the formulas and you substitute.
Yep, that's good. Then after that, I write it out, mgh at point A plus 1/2 mv squared at point A is equal to mgh at point B plus 1/2 mv squared at point B. Yeah, that's good. Then now for the substitution, I know the h at A, so I'm just gonna say, okay, I didn't give the mass of the person. I'm just gonna give it out even though it's not important. I'll say he's 60 kg. Yeah, so 60 into 9,8 into 8.
Oh, 8. Oh, okay, I see it.
Yeah, Then VA is what we're looking for, right?
Mm-hmm.
Yes, then 60, 9.8. HB is going to be 5 plus 1/2, 60. What about VB?
Velocity. So isn't velocity 0?
Okay, yes, but we do need a reason for why it should be 0.
point, at point B comes to a stop and then he goes back into motion when he goes back.
Yes, exactly. So you need to swing to B, grab the apple, that's all we need, then we can swing back. We don't need to pass point B. So the speed there should be 0 squared. So can you see that now you only have one unknown, which is VA?
Yes, sir.
Yes,
Yes,
yep, that's how simple these kind of questions are. So that is a pendulum.
oh, oh,
Yes.
oh no, so you can continue, sir.
Okay, yes. So something I want to mention, that's basically the last of it. You can just find the answer for yourself there, just to practice with that example. I did see it in the exam, by the way. I just don't remember what exactly it said, so I just formulated my own. A pendulum or mechanical energy, just to wrap it up, if I start from this height, let's say I have a pendulum. A pendulum is just this thing with a bob attached to it, and then I hold this at rest. What I have here is potential energy or gravitational potential energy due to the height. This thing is not moving, so every energy that is in here is potential energy. And then I'm just gonna show the graph of, by the way, you can get a graph in multiple choice usually, and then they'll say which graph actually correctly represent what is going on here. So let's make a graph explanation for this. So on the Y, we're just gonna have energy in joules. On the X, we're gonna have, I'll say time. Is it time? Yeah, it's time. Yeah, it is time in second. Okay, so if I just plot the value of energy for this thing at that point, I'll just call it point A. It's gonna be at a maximum. That is all the energy that this thing can have. And then I'll use a blue pen for this. So it's this energy. I'll just say EP for this case. And then I'll go all the way to this point. And I'll call this point B. At point B, what is the potential energy there?
0.
It's 0. So you go
Yes.
all the way to 0 like this. Yep. Then we can fill out the energies here in the middle, and you can see it's going down. The energies are going down like that. So what we see is that the potential energy is actually doing this. Oops. I'm just gonna need a shape to help me draw this one. It's going down like that. Then let's look at the kinetic energy. What is the kinetic energy at point A?
0.
It's 0. What is the kinetic energy that we expect at point B?
It should be higher than at point A.
It should actually be the same at point A, because all the potential energy that was there at point A is now converted. All of it is now converted to EK. Make sense?
Yes, that makes sense now.
Yes. So at that time, then the kinetic energy should be exactly the same position as the potential energy. Then if you actually do your maths with those values of the function, you're going to get EM if you add them all. So EP plus EK. For example, at point B, there's no EP, there's just EK. At point A, there's no EK, there's just EP. But at this point, right in the middle, all the values are halfway. it's at this point here. If I add all these points, if I add all these function values, I get EM, which is going to go from maximum to maximum. So EM stays the same. It stays the same value. This is the graph for EM. The red one is the graph for EK. The blue one is the graph for EP. I don't know if the point I'm trying to make makes sense.
So it makes sense.
Yes.
Yes, sir.
Yes, thank you. So the mechanical energy doesn't change. It stays the same value. I've seen this in multiple choice and it really troubles a lot of learners. But yeah, that's what you actually expect. Mechanical energy, the same all the time, because even though we don't have one of the energies, these two are just going to pour into each other. If there's no kinetic energy, there will be potential energy and vice versa. Okay, so that's the kind of relationship. Yeah, that's what I wanted to say. What is the time now on the clock? 17:53. Is there any other question on this?
No, sir.
Okay, because from here on yes.
Well, so I was thinking, because I am writing physics first, is it possible to get more energy questions that I can practice? Because I
Oh
can't
yes.
seem to find any.
Oh yeah, I'll send the questions in the group.
Thank you, sir.
All right. I wanna go to multiple choice if I have multiple choice here and see the kind of question they have for energy in this question paper. Let's see. Do they have energy? Yeah, they do. They say on 1.5 that an object moving at speed v has kinetic energy E. The kinetic energy now changes to a quarter of E. Okay, there's those kind of questions again. So they say that when the speed is v, the kinetic energy is E. Then what happens if we actually change the kinetic energy? So new kinetic energy. Anyone with confidence to actually give this one a shot?
Yeah. So let me try.
Okay, you can try it. Remember what we did the last time. You
Yes,
just
sir.
need to write the equation for kinetic energy and do your magic.
So,
Is it not working out? Mulwedi, are you trying it as well?
Um, so let me try it.
Okay, let's try.
Yes, sir. Mm.
Yes.
Um,
Do you know how to make something the subject of the equation?
yes, sir.
Is this correct for V?
Yes, sir, it is.
Yeah. But you don't have to complicate it. I'm just giving a clue. Looking at the time, it seems like we don't have much time. So I'm just going to try it and then you'll see what happens. I'll use that equation that is in terms of speed because that's what we're looking for. And then I'll try to isolate the equation such that I have this thing factored out. Okay, so this is going to be V is equal to, now I'm actually not gonna have V there, I'm just gonna say equal to now, or let me say new V is equal to, so I'll say the square root of 2, now the E changes to 1 over 4E, so I'm just gonna have 1 over 4E like this, divide by M, but I need to isolate this thing. Remember, we need to factor out the thing that we start with because that is the
Oh,
thing that is equal to V. Therefore, this is equal to square root of, I'll pull the half, the 1 over 4 to the front, and then I'm just going to have 2E, and then this is divided by M, right? Therefore, you know that this thing can be written as 1 over 4 multiplied by, the square root of 1 over 4 multiplied by 2E over M. Are you aware of that?
yes, sir. Or the square
Yes.
root.
Yes. But we recognize square root of 2E over M as just V. So, and square root of 1 over 4 is how much?
It's a half.
It's a half. So the correct answer for this is half V. It's too much, ne? I'm just gonna teach you how to just remember these ones. So the first thing you want to do is to understand the equation. That's the first thing. The second thing is to say whether the two things are directly or inversely proportional, right? What do you think for
Yes,
these
sir.
two? Direct or inverse? E and V?
Oh, so E and V,
Yes.
they are direct.
That
Yes, they're direct.
they are directly proportional. When V increase, E has to increase,
E
isn't
also
it?
increases.
Yes. Therefore, because there is a squared, you see, if there is no squared like M, then whatever factor that the other one is having, it's going to be exactly the same as the other one. But because there is a squared, this means the factor has to be under the square root. So in other words, if I need to find 1 over 4 of 1 over 4e, then this means I need to take the square root of 1 over 2. I need to say 1 over 2 v squared in order to get 1 over 4 v squared. I'm not sure if this makes sense.
Oh,
So
okay, it makes sense.
yeah, this already isolates the final answer for you, so you don't have to go into trouble of doing all this calculation here. So can we see that?
Yes, sir.
All right. Mulwedi, are you also fine with this?
Yes, sir.
Okay, are you sure?
Yes, sir.
Okay, all right, that's good. So I'll see you tomorrow, guys. Be on time so that we can look at other things.
Yes, sir.
Cool.
Okay, sir.
Thank you. Bye.
Bye, sir.
Bye bye.